Okay, guys. I think for your batch, I'm handling first time. I'm handling first time. Last year, I'm not handled any subject for your batch. So myself, Anil Naik, and I'm handling computer organization and architecture subject. So this subject in this you will study about the computer organization concepts and the architecture concepts. So the prerequisite for this subject is uh, digital logic design and operating system concepts. So you are already gone through the logic design subject, digital logic design. So here you will understand about the fundamental blocks of building the computer system, interfacing techniques of these blocks to achieve the different configuration of entire computer system. So at the end of this course, you will describe what are the functional architecture of the computer system. You will analyze various algorithms for arithmetic computation and arrive at fastest one. Means you will study about the fastest algorithm for multiplication, division, and also you will study about ARC processor, a risk processor. RISC and CISC, these are the architecture of computers. So a ARC processor is a 32-bit processor. So in your last semester, I think you gone through the microprocessor. Microprocessor is a how many bit processor? How many bit microprocessor you are studied? Anyone? Anyone? How many bit microprocessor? I think you are studied 16-bit 8086 microprocessor. Yes, 16-bit microprocessor. So when I ask the question, you just try to give the answer in the chart. Then, similar to that, it's ARC is one processor that assembly language processor is the 32-bit processor and demonstrate the design aspects of memory, instruction level parallelism, and multi-processor. So these are the concepts that you will study in this subject. So now I want to know. So anyone, you can share in the chat what you know about the computer. Computer, what are the different functional units of the computer? What are the main components of the computer? Yes, you mention in the chart. Otherwise, you can speak also. Different function or components of the computer. Yes, Abhishek. Abhishek, can you hear me?
Yes, sir.
Okay. So, can you tell me what are the different functional units of computer?
Yes, sir. Mainly the computer, basically it divides into two parts, the computer hardware and computer software.
Okay.
The
Then.
computer software is the set of rules or protocols which communicate with the hardware. By combination of these two, we can run any function we want on computer.
Okay. So, can you tell me the different components?
Yes, sir. Means there are some hardware parts, sir, like monitor, mouse.
Hmm.
Main is the central processing unit, CPU, motherboard.
CPU. Yes. CPU. Then what are the input devices?
Input devices are the mouse, keyboard,
Okay.
and the output devices are the monitors,
Hmm.
printers, scanners.
Okay. Then what about memory? Memory concepts.
Yes, sir. There are two memory types. Nowadays, there are also third type is there SSD, but basically there are two memory. One is RAM, that is main memory, and second is the secondary storage memory.
Hmm.
So also we call that as a ROM, read only memory. Uh, and nowadays there is one concept is there, SSD,
Hmm.
which is used for the application to run very fastly. So that's why SSD is nowadays used for that
Hmm.
purpose.
Then so RAM or a random access memory.
Yes, sir.
What is that?
Sir, random access memory is the
Is a
main memory.
permanent memory or temporary memory?
Sir, it is a temporary memory, sir.
Hmm. Okay. So SSD flash memory. Okay.
Yes, sir.
Okay. So you will study about the different type of memories. So memory, primary memory, secondary memory, and different other memory concepts like cache memory and instruction level parallelism. So instructions are executed parallelly to handle the large number of instructions. For example, in the processor, we call it as dual core processor, quad core processor, octa core processor. So dual core processor means the different two cores they parallelly handle the different tasks. Quad core, four cores, four core that parallelly they uh, handle the different units. Means parallelly all the four cores they will handle different tasks at a time. So that's why instruction level parallelism is very important. So that's why we purchase the mobile phones or the any computing devices that is having the more cores, quad core, octa core. So whenever we buy new system, so we'll go through these configurations, multiprocessors. Okay, so these are the course outcomes that you will study, and also we'll go through the sections. In the section one, you will study about the introductions. First, in the first chapter, we'll study about the almost the history of computers, history of computing devices. Then von Neumann model and different generations of computers. So now we are living in the fifth generation era. So different generation. We even nowadays we call it as fifth generation or sixth generation computers. Then sixth, then system models, the different levels of machines, levels of computers. Then in the second chapter, we'll study about different data representations and arithmetic operations. Data representations, fixed point numbers, floating point numbers, and here we'll study about algorithms. We'll study about the fast multiplication algorithms that is called as the Booth's algorithm, and in the division algorithm we'll study about restoring, non-restoring division methods. So means these are the some high performance multiplication algorithms. How the system is designed to compute the mathematical operations. And floating point numbers. Floating point numbers means the large numbers that you can represent in a small format. Floating point numbers. Floating point numbers. So here 1 into 10 raised to minus 8. So it's a number 0.00002. So such a large number that they represent in a small format. So that is a with the extension 2 raised to e. So that is a floating point number. So you can see here, this is the one large number. So this will study IEEE 754 floating point standard. So the main advantage of this floating point number is that the large number you can represent in a small form, like a 10 raised to minus 50, 2 into 10 raised to minus 99. So such a large number, like 10 into 2 raised to 25. 2 raised to 25. Such a large number that we represent in a small format. So that is a floating point numbers. Then we'll study about instruction set architecture. So as I told, ARC processor, a RISC is a computer architecture. CISC and RISC, reduced instruction set computer. It is a one type of RISC type of computer, 32-bit processor, and here we will study about the complete. It is like similar to the 8086 microprocessor, but here we are not discussing in depth. We are discussing the pseudo operations, the instructions format. We are not studying in detail about all the instructions. Then fundamentals of computer design, the computer architectures, then how the power in integrated circuits, like power consumption, the cost. So this is about all the fundamental concepts of computer design, like power consumption. We will study in the first chapter in the history of computer. So you know the first generation computer and now in the fifth generation computer, it's a very different in the size and all. So just I want to know from your side. So can anyone know the different generations of computers? First generation to fifth generation, first generation computers, first generation of computers, such a large size computers, such a large size computers. So these are the man. He's working in a computer. So he's doing some maintenance. Okay, one of your friend is facing problem. Unable to join meeting. So those who are not able to join, so is there any others? Those anyone facing the problem?
Sir, actually, they requested you to join lecture.
Request. No, you just tell him to send one more time request. So if any of your friend is facing the problem, just you mention them to send the request. So what happens when I move to that PDF? When I move to PDF, so that's why it is not taking the auto admit. So now I am in the this Google Meet. So you just you inform your friends to send the request. So who is that person? Ruchika. So is Ruchika joined? Yes, joining. So I think there is no problem from my side. So anyway, I'm recording the sessions, and if some people unable to join, so they can watch the video later. So then in the in this chapter we'll study about the different the computer design concepts, the power consumption and all, integrate power consumption in the integrated circuits, cost, and also we were discussing about the first generation computers. Okay, so this is such a large size computers, and also if you face any problem in the middle, you can interrupt. You can suppose if it is not audible or if any other problem, so you can interrupt me in the middle. So these are some large size computers. The person he goes to inside and he do some maintenance. And these devices they consume a lot of power. Cost also cost also more. And in the second section, we'll discuss about the fundamentals of pipelining. Pipelining is a approach to make the instruction execution faster or to complete to complete any task in your computer. It's very fast. So pipelining techniques. Because nowadays you purchase for mobile application development and all, so you require a computer with minimum 16 GB RAM, minimum 8 to 16 GB RAM, because the computational power it is required is more. So we can handle such a complex task with the pipelining techniques. Pipelining that execute the instructions parallelly. That instructions execute parallelly. So that is the main advantage of pipelining. So, like for example, you can observe in the mobile devices. So high configuration mobile devices that works or operate faster than the low configuration devices. So you can compare with the 8 GB RAM mobile devices and 2 GB RAM mobile devices. So how how the different functionality works, and it supports to the large you can do the multitasking. You can do multitasking, like you can open a browser, you can watch movies, you can listen to audio, different multiple tasks you can do. So that is all because of the pipelining techniques. And because of the pipelining technique, there are some hazards also occur. Hazard means problems. Okay, so how to overcome those problems and all we'll discuss in the fifth chapter. And also sixth and seventh also the same. It's a instruction level. It's also extension of the pipelining techniques. And multiprocessor concepts that we'll discuss in the last chapter. Memory sharing and all, distributed shared memory, directory based. So these are all the multiprocessor concepts that we study in the eighth chapter. So these are the textbooks that computer architecture and organization integrated approach by Miles Mordocca. So this first textbook that you will get, the PPTs you will get, and there are three units that cover in this first textbook, and the second textbook that covers around 5 chapters, 5 units, 4, 5, 6, 7, 8. So that covers in the second textbook. That is this one, Computer Architecture and Quantitative Approach, John Hensey and Patterson. So fourth edition, and for first chapter, all the PPTs are available in the Google. Then computer architecture, this textbook is also available. E-copies are available. and computer organization architecture. So this also you can refer for the last the second section topics. Then reference books. Then I see. So you are having a tutorial for this subject. Tutorial is for students can carry 8 to 10 assignments. So here these are the different case studies about what happened to supercomputers, then Patriot missile defense failure, then multiplication using Booth's algorithms, division. So these are some case studies. So for this tutorial, even you have to use the simulators also, simulator to perform some of the assignments. So in such cases, so for these assignments, you are I am referring the uh, IIT Kharagpur. There is a virtual lab is available. Virtual lab for your tutorial work. For your tutorial work, so all that instructions I will provide through the your what is this classroom. Through classroom, I will communicate because you have to submit assignments and quizzes and test everything from the classroom. So I request this is there are few peoples are not joined. So like Chintan Jain, H Jain, it's Raut. So these people they are not joined. Kunal, you just inform to your these friends Gaikwad, Kharat. So these people they are not joined to the classroom. So you just inform to these guys and tell them to join because whatever your tutorial work, so that I will communicate through only this classroom. Okay, so this is the so you can take a screenshot. Suppose if you are not joined, you use this code to join the classroom. I already sent this code in the uh, WhatsApp. So your tutorial work for that your tutorial and assignments, I am referring the Google Classroom. So now come to the first chapter. So in the first chapter, so is it visible? Can anyone say yes? Is my slide
Yes,
visible?
sir.
Okay. So we discussed about the syllabus, the total 8 units, and the textbooks that I will share in the through Google Classroom. The all the materials, PPTs, and the textbooks. The one thing is you keep in mind. So this subject previously it was two subjects. Like computer organization was separate, computer architecture was separate. But for even for from last year they are combined into one subject because the that for IT students they are given more focus on the programming, like that's why they are added Python and all. So this subject in this you will study about all the basic concepts of the computer and how we can modify, how we can develop the new different computer architectures. So in the first chapter, we'll study about the history of computers. So today we'll discuss about the history of computing. So history of computing means so before that we'll uh, define what is COA. COA means computer organization and architecture. COA means computer organization and architecture. Computer organization and architecture. First, you should know what is computer architecture and what is organization. So, computer organization is concerned with the way the hardware components operate, the way the different hardware components like input unit, output unit, memory. So how these hardware components they operate, or and the way they connected together, the way they connected together, the different components, and how they connected through the buses, how they pass these different components. Okay, so how these different components they connected together to form a computer system. It includes the hardware details that are transparent to the programmer, such as control signals, peripherals. So these control signals, the control signals that you already know in microprocessor, uh, how it controls the operation of the devices, signals, control signals, and peripherals. So computer organization, and it describes how the computer performs. The example like the circuit design, control signals, memory, these are all types that comes under the computer organization. Computer architecture is also concerned with the structure, behavior of the computer system that are seen by the user. It includes the information format, like we say 32-bit machine, 40 no, 32-bit machine, 64-bit machine. It specifies the instructions, the format and instruction set, like 8085, that processor, say 8-bit processor. So this processor architecture is different than 8086 processor. So how many bit is that? It's a 16-bit processor. So 16-bit processor architecture is different, that you know. And in similar to that, like 80286, 386, 486, that you know. So the each processor is having the different architecture. Similar to that, in this subject you will study about ARC processor. It is also having the different architecture. So each processor is having their own information formats, instruction set, and techniques, techniques for addressing the memory. So it describes what the computer does. It describes what the computer does. So some of the definitions are like computer architecture that deals with the functional behavior of computer system that is viewed by the programmers, like it is a 32-bit processor or 60-bit, 64-bit, like. And computer organization deals with the relationship that are not visible to the means is the relationship between the different components. So this is the difference between the computer architecture and computer organizations. So what is the purpose? Purpose means the computer architecture that explains what a computer should do. Architecture is specifies what the computer should do. The computer organization that explains how the computer works, how the different functional units, the different components, different hardware components, how they works. That is computer organization. So what is the target? The computer architecture that provides the functional behavior of the computer system. So it specifies the relationship between the different parts of the computer system. Computer architecture that deals with higher level design. Higher level design, and it is a lower level design. Higher level design means like computer architecture, like the architect, you can say the architecture of house, or you can say the architecture of 8086 processor block diagram. I think you remember the block diagram of 8086, 8085 microprocessors. So that specify the high level computer architecture. High level, the computer like registers, then different other function, input port, output port. So that specify the high level design. And computer organization deals with the low level design in detail about the register. So in the register, what are the different type of registers? Actors in the computer architecture are the hardware parts, the different hardware. and the computer organization performance. The order computer architecture is designed first, and computer organization is started after finalizing the computer architecture. It's like how the construction of a house. While construction of a new house, first we'll prepare a blueprint or the blueprint, or we design the house with the 2 BHK, 3 BHK. There is a plan, house plan. So that is computer architecture. It's like a computer architecture. So after that, we will start the work. So that is computer organization. So first that comes the computer architecture, and the next comes the computer organization. So this is about the computer organization and architecture concepts. Then we'll study about the history of computing. So history of computing. So before discussing the history of computing, so I want to know from your side, history of computing. So history of computing. So can anyone tell the past different computing devices that they used, like in the early generations? Anyone remember the abacus? Abacus. I think nowadays in the playgroup, small children they use the abacus device to compute the for calculation purpose. Mm, Abhijit Vishwanath, can you hear me? Vishwanath,
Hello, yes, sir.
uh, do you know any computing devices other than computer? Means it should perform some operation. Like
Yes, sir. We can see mobiles,
mobiles.
micro,
Then
microcontrollers,
microcontroller. There. No, history.
like
You go. I mean, like history. History means in the early generation.
supercomputers, sir.
Yes.
Supercomputers.
Supercomputers. Even nowadays also, we use the supercomputers with a high configuration. Okay. Uh, okay. We'll go through the history of. So in the history of computer, just go through the slide. So in the 25,000, 30,000 BC, means around the 500, 600 years back, they were uses bone of animals to like notches in the objects such as bones. So this is the animal bone. So this is a animal bone. Animal bones are used to mark some, like this figure. So this is the taken from the 1937 one of the newspaper. So it is showing a 55 cuts in groups of five, like this, groups of five cuts, suggesting a rudimentary form of multiplication or division. So they used to like mark on the bones, animal bones. So this is one type of devices. Then tally sticks in the 12th century, the people they uses the tally sticks like this. So this some shape is there here. Tally sticks they are used, and you can see here there is some mark is there on sticks. Tally sticks, wooden sticks. Here also some design is there. So original wooden tally sticks. Westminster, England. So in the England, the people they use this in the 12th century. So they used to people such type of sticks. Then Chinese abacus. It is also one of the type of the computing devices. So I think you people know this one. So this is one middle bar, and so the top bits that indicates so okay. So this the top bits that marks as a 5 points, and this is one value is one for 1 bits. So this is the value 39017. What it indicates? So here the bits are not near to this bar. If it is near to this bar, then the value counts. Like here one, two, three. So value is one. So here three bits are the three, and here there is no bits. So this the value is three. And for this case, one, two, three, four, and here one bits is there. So this value is five. So five plus four, so nine. So in such actually the playgroup, small children's playgroup, they use this, they give this such type of devices. Nowadays also we are using this Chinese abacus. Then cylinder music box. So Victorian Swiss cylinder music box, that is dated in 1862. In 1862, it is a mechanical device that used for controlling some complex operations. So So this is, I think, they used to this knob. They use actually you can go through. Just I'm showing the history of all the different computing devices. For more detail, you just go through the Wikipedia of, by mentioning the device name. Then Pascal's calculating machine. So this is the Pascal's calculating machine that performs the basic arithmetic operations early in the mid 1600. So it does not have what may be considered the basic parts of the computer. Means, it was one of the device that performed the arithmetic operation, but it does not having like computer input device, output device, input output device, and storing memory. Memory was not there. So so it was not having some of the basic parts of the computer. We can't say it is a computer. Okay, it is a Pascal's calculating machine that used to perform some like basic operations. So Pascal developed the mechanical calculator. It's a calculator that helped in his father's tax work for the tax calculation. So the Pascal calculator, Pascal line that contains the 8 dials that connect to the drum. So nowadays these such devices are available in the museums, and there are some videos also available, so you can see the working how it works. Then it's a Babbage difference engine. This is also automatic calculator. This is a automatic calculator that is used that is developed by the Charles Babbage difference engine. That working portion of the Babbage's difference engine number one, which is the first known as automatic calculator. So it was a mechanical calculator, mechanical Pascal calculator, but they improved that, and it is an automatic calculator that calculate the. It is similar to the calculator like our one into three, three, 8 into 4, 32. Like normally we do in the our calculator. In the similar way, they used to use such devices. Babbage, Charles, Babbage difference engine. We call it as difference engine. So Charles Babbage is sometimes referred to as the father of computer. He never built a practical version of the machines he designed, but Babbage's machine had means for reading the input data, storing the data, and performing the calculations and producing the output data and automatically controlling the operations of the machine. So this is the Babbage machine that it is based on the concept of it is taking the
Hello,
input
Naik
and
sir, Nirgude madam here.
uh, yes madam. Yes madam.
Naik sir,
Yes madam, I can hear. Yes madam.
hello.
Yes, yes madam, I can hear. Hello, yes madam. Can you hear me madam?
Sir, can you continue for 15 minutes?
Yes madam, yes, I can continue. I'll continue madam. Hello, hello. So, yeah, I will continue madam.
Sir, you are not
Okay.
audible.
Yes, now madam. Hello. Yes guys, anyone say, am I audible? Yes, students.
Yes, sir.
Okay.
Sir, you are audible.
Okay, I will. Okay. I will continue. Okay. So we were discussing about the Babbage difference engine. So in this it was an automatic calculator that is developed by the concept of by the concept of Charles Babbage. So it is used to take the input and process the data and performing the it produces the output. So one more device that is Enigma. So Enigma cipher machine. So this machine it look like a typewriter. So it is used to exchange the encrypted message by the engine. Encrypted messages. Encrypted message like the sender he actually military people they use such type of devices. So encrypted with with the different format. The
Media volume model.
so encrypted. They used to send the encrypted message to the. So this was the original message, but this device it converts into some other form and it's sent to the sender side. Then this is the one more device, Calulus. Calulus. The Calulus was a successful code-breaking machine. Calulus was a successful code-breaking machine that came out of Bletchley Park. It was based on the concept developed by the
Naik
Max.
sir,
Yes, madam.
can you continue for 15 minutes?
Yes, madam. I will continue.
Okay, thank you so much.
Okay. Okay.
Yeah.
Okay, it was one of the machine, and it is developed by the Max Beumann and designed and constructed by the Tommy Flowers. It is used to solve the problems that is posed by the mathematicians. So it is a complete one device. It was a one computer. It was a like it is similar to the computer. It is not a perfect computer. So machine is used to perform the mathematical calculations. So here you can see how the changed from Pascal to the Babbage's difference engine, that is automatic calculator, and then they used to send the encrypted messages, and then Cololus, that machine that is also used to perform the some mathematic operation, and this is the first computer we can say, the electronic numerical integrator and computer. Electronic numerical ENIAC, that is a first computer we can say. So here you can see the person who is doing some maintenance work, and here the number the people there, you can see here the number of people they are roaming inside the computer and they are doing some maintenance tasks. So this was the first computer. So nowadays I think now you people are using a small device, small laptop. You are using a small laptop or the small mobile devices you people are using. So you just compare such a large computer to this laptop or mobile devices. How the change in the technology. So there are different factors, different parameters. So that concepts we study in the second section, that is computer architecture. Computer architecture. So this is the ENIAC computer, first computer. So these are all wires, different devices. So ENIAC was a modular computer that is composed of individual panels to perform different functions. 20 of these modules were accumulators, which could not accumulator means the registers, which could not only add and subtract but also hold 10 digit numbers in the memory. Okay, so the accumulator which could not only add and subtract, it is used to hold 10 digit numbers. So that computer ENIAC, that was whole, it holds the storage, it was storing the data, it was storing the 10 digit data in a memory. So ENIAC contained the 17,468 vacuum tubes. So it is a main processing device in the first generation computer. Vacuum tubes, 7,200 crystal diodes, 1,500 relays, 70,000 registers, 10,000 capacitors, and approximately 5 lakh, 50 lakh, around 50 lakh soldered joints. It weighted more than around 30 short tons, and it covers around the size 1800 square foot. The size of the, it's like one that construction house plot, we can say 1800 square foot, and it consumed around 180 150 kilowatt of electricity. So it used to consume more power. That was the drawback. That was the drawback in the this first generation computers. So here you can I will show the vacuum tubes. Vacuum tubes. Vacuum tubes. Yeah. So the first generation computers were having first generation. So these are the vacuums. Uh, so these are the vacuum tubes. So the first generation computer, it was having around uh, yes, guys, is it visible? Say anyone yes.
Yes, sir.
Okay. So this is the vacuum tubes. So this is a main processing device. So nowadays, what is the main processing device in your devices? Like the main processing devices in your computer, like the RAM, your hard disk, and all the main processing devices that perform some of the calculations and store the data. So your processor, your Intel dual core, Core Duo, octa core processor, quad core. So such devices are the main processing device in the computer. And in the first generation computer, this is the vacuum tubes that used to perform the operation in the, and there were how many, 17,000 vacuum tubes were there. It looked like it is a bulb. So it looked like a bulbs. There are 17,000 vacuum tubes were there in the. So this first generation of computers, so these components you can see in the Bangalore Visvesvaraya Museum is there. So in the Visvesvaraya Museum, so you can see these computers. They are kept in a museum. So you can see these all the different vacuum tubes, first generation, second generation computer, everything you can see in the Visvesvaraya Museum, Bangalore. So ENIAC, this it consists of around yes, vacuum tubes, and there is the computing section of the machine. Programming and data entry are performed by setting the switches and changing the cables. So they used to change the cables and setting the switches, and there is no concept of stored program, and there is no central memory unit. It was used for around 9 years after the 1946. 1946. So the first working demonstration of a stored program computer, however, it was designed and developed by the F.C. Williams and Tom Kibum. So these are the scientists, they F.C. Williams and Tom Kilbum at the University of Manchester. And this was small scale experimental machines that is known as baby. So this is for this machine we can also call it as a baby on June 21, 1948. The enhancement to the baby that led to the Manchester Mark One. The name they changed to Manchester Mark One, which became the fully operational in 1949. So actually they started to work in the 1946. So it was not complete functional. So they're working on that. In 1948 they given the name as baby. It was a small scale experimental machine, and they enhanced the features, and it was fully functional, fully operational in October 1949. So, so that was the first generation computer, ENIAC. We'll study and then tomorrow we'll study about different generations of computer. Then Moore's law. Moore law. So I think you know Moore law, computing the power that doubles every 18 months for the same price. Means in the every device, Moore he told about by observation that over the history of computing, the number of transistors in the integrated circuit has doubled approximately every 2 years. So in the 1965 paper, in the 1965 in a research paper, he was mentioned the 1965 research paper. More he was mentioned that after every 2 years, the transistor count will be doubled. So, like for example, the four bit computer, fourth generation, the third generation computers, 1970, these 4004 processor, 8008 processor, 8 bit, 8088, 8-bit processors. Okay, so the number of transistor count was around 7,000, around 6,000. Then in this around this period in 1978 or something, the transistor count, it was in every year the transistor count was doubled. 10,000, 1 lakh, 10 lakh, 1 crore. So as the Intel family, the processor is they 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 improved their versions. Intel Pentium 4. So it was up to only Titanium. So you can see the present other graphs. So it was the graph that shows only up to 2005. So nowadays you can see there are trillions of transistor count in a small processor. So that you can see in the Intel family processor, Intel family, Intel family processor. So it was up to IS7 processors. Transistor count. It was old one, and okay. So this chart it gives up to 2028 to 2018. 2018. So here you can see the Morella, whatever the More he said, every 2 years the transistor count will be doubled. So in 1970, it started from the 1970, and how the transistor count is increased. These are different processors. I5 processor, I3 processor. So here I3 processor, I7 processors. So the transistor count is doubled. So in your whatever the laptop or devices you are using, so that contains around billions of transistors. So his observation was he mentioned such that concept in 1965 only. In the 1965, the co-founder of Intel Corporation and Fairchild Semiconductor in 1965 paper described doubling year, every doubles every year in the number of components per integrated circuits. So it was about the history of computing. Okay, so if you have any doubts, we can discuss. With this, I will end the session, and in the tomorrow we will discuss some more concepts. So, if you have any other things that you want to discuss,